This next experiment has become a classic. It's the Whoosh bottle experiment. Here we're looking at the combustion, the complete combustion of a fuel. Now there are three possibilities of fuels that can be burnt in a Whoosh bottle. A Whoosh bottle is merely a water canister that has been removed from the water supply. We can use the alcohols methanol, ethanol or propan-2-ol. In this experiment we're going to use methanol, and that's what the equations refer to. To do the Whoosh bottle experiment we need to produce some vapor. Methanol and the other alcohols are highly volatile, so shaking them up inside of the plastic bottle causes some of the liquid to vaporize until the air above it reaches saturation. Of course there is still air above it, so there is still oxygen. We pour out the surplus alcohol so that we have a fuel-air mixture in the container, and then remembering the fire triangle from when you were younger scientists, we need some activation energy to get it going, so we're going to provide that with a flame on the end of a spill. The combustion shows the conversion of chemical energy from the fuel-air mixture reaction being released as heat energy because the bottle gets warm, as some light energy because you can see a flame, and as sound energy. One of the chemical products of complete combustion is water, which you can see being poured out of the water bottle. That was perfectly dry to start with, and I'd already emptied out the alcohol. The second one is carbon dioxide, which we haven't tested for in this video clip. Of course you could use lime water to go from a colourless to a cloudy mixture, should you so wish. We've repeated the experiment in the dark and in slow motion. We can also reproduce the flame test for sodium in a Whoosh bottle, and it's appropriate to put here. Complete combustion always leads to blue flames. Incomplete combustion would lead to a yellow flame due to carbon particles that have been produced as part of the reaction. The carbon can go on to give carbon dioxide with further oxidation, so incomplete combustion would be an inefficient way of burning materials. When we put some sodium into the alcohol, and we dissolve the sodium into the alcohol, enough of it remains in the vapor state to give the characteristic yellow flame of sodium. This shouldn't be confused with incomplete combustion. We have tried other flame test metal ions, but they are too insoluble in methanol in order to give the other flame colors.